Hello and welcome everyone to our session From Machine to Digital Services. I'm super happy that so many of you guys joined. I'm David. I am part of the AWS Solutions Architecture team for manufacturing. And today I'm pretty excited to share the stage with one of our customers, Heidelberger Druckmaschinen. Specifically, Matthias, who is product owner in one of the key platforms that we are going to share with you some more details today. And also Jörg, who is a key architect in that project. Before we hear more from Heidelberg, and I'm pretty sure you're very excited to hear from them, I want to share a quick fun fact with you. So each and every one of you here in the audience, probably within the last 24 hours, was in some way or another in contact with one product that was manufactured or printed by one of Heidelberg's machines. Right? So if you now think back what you did in the last 24 hours, well, it might be the shoebox of your favorite sports shoes. It might be the cosmetics packaging of the cosmetics product you used this morning in your hotel bathroom. Or it might even be the label on the beer bottle that you drank last night with your colleagues when you went out for beers. So I hope you're all well recovered by now to pay attention to our session. So really what I want to tell you with this is the products of many manufacturing companies here in Germany are all around us, and they often are the basis of our everyday life, obviously. And we from AWS are pretty passionate to share, to support customers like Heidelberg on their digitalization challenges. About such a digitalization journey, we are going to hear today from Heidelberg. We are going to hear how Heidelberg, you could call them a poster child for German engineering, how they, with over 170 years of history in German precision engineering and machine building, leverage cloud technology and services from AWS to build a suite of digital services and use this, what they call a digital ecosystem, as a key building block in an entirely new business model they are right now pioneering on the market. So they call it Heidelberg subscription or equipment as a service. And we're going to hear in a second what that means in detail. Also, we are going to hear how the technical architecture behind that really looks like. And Matthias and Jörg will share some pretty interesting lessons learned that they learned really over the course of the last 3 to 4 years. Now, before we dive into that, I would like to set the context a little bit. So maybe not everyone here might be super familiar with manufacturing or what AWS is doing in manufacturing. And well, our goal is really to support customers and enable them to leverage cloud technology over their entire product lifecycle or over the entire value chain. So that means going from product inception, over manufacturing the product, up until bringing the product to customers. Now, when we look at product design, we have a solution area we call engineering and design. And that really revolves around leveraging cloud technology to develop your products faster. Right? For example, accelerating time to market by using modernized engineering applications in the cloud or scalable high-performance compute clusters to do your physical simulations quicker. The second solution area we call smart manufacturing or smart factory. That really means making your shop floor smarter where you build your products, enabling data-driven decisions with data coming from your shop floor, or using one of the many purpose-built services from AWS to produce your products with higher quality and improved efficiency of your equipment. Now, the last solution area we are going to hone in a bit more today, we call smart products and machines. What this really means is infusing the product you build with smart technology. And not only that, it's also about using the data that this product generates to redefine your entire customer experience around that. And this often can have a quite significant impact on how you do business and on your entire business model, as we will hear later from Heidelberg. Now, what does smart products and machines really mean for a machine builder like Heidelberg is one? Well, as I mentioned, it comes with sometimes a quite significant change in how you do business. And we see a quite significant shift from a merely transactional model, right? So basically selling the machine, selling the asset, maybe a service contract on top of that, towards a more service-oriented business model that means a continuous delivery of value from the data that such a machine generates, oftentimes through digital services, right? To make it a bit more concrete, that could mean real-time state information about the machine. This could be predictive maintenance, anomaly detection based on the data that's coming from the machine, right? So the use cases are really, the potential for the use cases are really quite big, and customers like Heidelberg come up with some pretty amazing solutions to make really, in the end, the experience for their customers they sell the machines to better. Now, since we work with a lot of customers, not only Heidelberg, across the German industry, we have witnessed a few key challenges when it comes to looking into such a digital ecosystem for smart machines, right? And the first talking point is usually the business model itself, right? So how do I finance that? Where's my return of invest? Will my customers really buy this, right? So quite a few challenges involved with that. And we are going to hear later from Matthias how Heidelberg tackled that challenge. The second point I want to make is many manufacturers are faced with a decision between building this digital platform or these digital services, or buying and integrating existing solutions like a ISV solution, like an IoT platform that exists already, right? There are typically good reasons for both, and both decisions come with some challenges by itself. Well, we believe manufacturers are builders at heart. And if you look at the amazing hardware products they build, then that's quite obvious. But that's also true for software, right? Many manufacturers have been building software already for 20, 30 years, but that's often embedded software or desktop software. Right? Now, when you go to the cloud and you become kind of a software as a service provider, this might require a new thinking and a new angle to the problem that might be perceived as a challenge. That also, again, brings me to my third point, which is culture. So culture, I'm not only referring to culture of how you do software development, small product-centric teams, DevOps, Agile, that's pretty well known already. But it also comes down to culture across your entire organization, right? So you need to get your salespeople on board, your legal people, right? Are your salespeople incentivized and equipped with the necessary skills to sell a software solution? Right? Might not always be the case, so that's also something to consider. Now, when we look at the more technical side of things, of course, every enterprise has a landscape of different solutions that historically grew over time, right? They might be quite heterogeneous, they might lack integration, they might have led to quite some significant data silos. And now when you want to make such a business model successful, you might need to tap into all of these different pools of data to make it work. Right? So this can also be a challenge. Now for implementation, of course, customers ask us, how do I actually connect tens of thousands, hundreds of thousands of assets across the globe, get insights from all of these machines in real time, and how do I do all of this securely, of course? And once you build this out, the big question mark is also operations. Right? So many manufacturers don't really have a lot of experience in operating software. And this comes again down to culture. With that being said, it's my pleasure to invite Matthias on stage, who will tell us a bit more about the amazing products from Heidelberg and also how they tackled those challenges. So, Matthias.
Thanks for the introduction, David. Well, starting this session, David told us about some print products that might have been produced on a Heidelberg press. And these prints are parts of the global printing market, which, even in today's digitized world, sizes around 400 billion euros a year in advertising, commercial, and packaging printing. This is really a huge market, and we believe it offers lots of opportunities for the print media industry. The scope of Heidelberg's core business is oriented to the whole value chain and its main target markets, which is commercial and packaging printing. We are delivering solutions to enable our customer to be successful in its markets. Heidelberg achieves a yearly revenue of about 2 billion euros realized by 9,500 employees, and we are active in around 170 countries across the world. We are also active in new markets like e-mobility, but our main market is the print media industry. For this, we are delivering several kinds of equipment as well as software to enable the end-to-end digitization. But finally, manufacturing of sheet-fed offset presses is the core DNA of Heidelberg. We are the market leader for sheet-fed offset presses with a market share of more than 40%. Sheet-fed offset presses, as you can see one on this slide. Well, I was told there might be more parts in such a Heidelberg machine than in a Boeing 747. Anyway, if this is true or wrong, a Heidelberg machine is like a Swiss clockwork in XXL. So we are proud of the machine quality Heidelberg finally stands for. And we are as well proud of the printing quality you can get out of such machines. It's really incredible which machine precision is required to get high-class prints. We are also proud on the performance these machines provides. It's enough to cover more than 2 soccer fields in an hour with printed sheets. And we also take pride in the machine reliability, which results in a machine life cycle of maybe 15 years and much more. So with that said, if you would have the chance to watch a Heidelberg machine while production, you shouldn't miss it. It's really fascinating. Let's talk about some challenges. Heidelberg is providing high-class printing machines to its customers with the increased machine productivity, machine generation by machine generation. Plus, Heidelberg as well delivers software solutions to the customers to optimize production processes in print shops. Well, both in combination results in a productivity increase at our customers of approximately 5 to 10% per year. And assuming a constant print production volume, this causes a massive impact to the Heidelberg core business. This motivates to think about new sustainable business models by increasing the scope to the customer success. And as a first step, we already started in 2017 with equipment as a service. This business model was to Heidelberg an entry point on the path in moving from a transactional business to a recurrent revenue driven by the machines. And reduced to its essential core, this business model works quite simple. Heidelberg delivers the machines and the consumption materials, and the customer pays by outcome. What did we learn from operating that model? Well, we learned that it's not only about to offer a new sales model. It's mostly about the availability of data and the ability to digitize all relevant processes to drive such a business model successfully. And it's also about integrating all relevant processes to scale such a business model successfully. And we learned as well that the customers were demanding for more subscription offerings addressing the whole value chain. So we extended equipment as a service to Heidelberg subscription by adding more subscription offerings related to the elements of software, service, plus training and consulting. Making each of these single elements successful would require a complete new view onto the availability of data. But making such a business model altogether successful would require the ability for a seamless integration of all these elements. Well, talking about seamless integration, I mean, for example, it's about the integration of equipment, software, and consumables to know about the usage of consumption materials at the customer side and to be able to deliver right in advance new materials that the customer can get the best out of the machines. Or it's about the integration of equipment, software, and service to offer predictive monitoring and to know about upcoming machine issues and to fix it before they would occur to guarantee the machine availability. And it requires to integrate as well equipment, software, and maybe training and consulting to notify customers in near real time about issues or anomalies seen related to productivity or machine operations, and to be able to enrich these notifications by a guidance of solution suggestions or by specific offerings of consultancy. So, as you can see, software and the availability of the data are the keys to redeem the value proposition of such data-driven business models. This is what we were talking about some years ago. And at this time, we already operated successfully several software solutions that contributes to these ideas. So we've been delivering successfully a tool suite of software components we call Prenect. And Prenect is explicitly made to automate and to optimize production processes in print shops. Originally built based on a 3-tier architecture and made for on-prem customer installation. So Prenect is one of the main pillars of software development at Heidelberg and also a major source of our experience related to software engineering. Next to Prenect, we've been doing, IoT since already 2005. Back then, nobody was ever even talking about this as IoT. We've been doing this IoT based on data ingestion of machine log files. So we already had a huge amount of machines connected, and we already gathered lots of data. And we ran a solution to enable our technical experts to support our customers in case of problems remotely. But finally, based on the history of that services, we were faced with a number of learnings from the existing solutions that might be known to other companies as well. I'm talking about the issue related to data silos. So we manage data in different solutions, and the data were neither linked to each other nor available for a general usage. We encountered high maintenance efforts and cost issues. So existing solutions had been what I would call made problem-oriented by a mix of own solutions and bought products, and it made it really hard to maintain and as well to innovate. We saw issues related to data consistency. So insights had been generated by different solutions in a different way, and at the end, the figures does not match, which results in a lack of trust to the figures shown. Well, we were faced with missing capabilities for a seamless integration I was already talking about, and last but not least, we missed near real-time capability. So based on the technology we used for data ingestion, further data processing could get started maybe hours or days after the data has been generated by the machines. So we learned that we can't map building new data-driven business models onto the existing structures successfully and sustainably. And we learned that we had to think about a new approach and about a new data platform. After getting this understanding, we had some intense talk about make or buy. And to be honest, there had been different opinions in the organization about this, which is still valid because there are maybe for each side different pros and cons. Finally, we decided to make a new data platform by our own and not to buy one. Why did we opt to make? Well, the main argument pro make is the strategic importance of the data platform and of the accessibility of the data for the success of our business models. So we are convinced that we have to keep the data in our own hands. We voted to make as well simply due to the matter of speed. We know about the importance to be able to react flexibly and quickly to upcoming demands and to feedback. And finally, we voted to make as well, because of the flexibility, to integrate services seamless. So we asked a small team to set up a new cloud-based data platform, and that could get used as a future base for our data-driven business models. And with that, I will hand over to Jörg, who will talk to you how the teams managed the challenges, which steps they took, and what they finally learned from.
About 3 years ago, Matthias and me sit together. It was February, it was cold outside and rainy, and we thought about how can we build a new data platform and make near real time possible and keep up the speed and stay effective. We first set up some cornerstones. We said the team and the project, they should be independent, so the team shouldn't depend on others. They should be able to solve all issues ideally by themselves. The second one is they should be open and free on the technologies that they want to use. And the third one is they should iterate really quickly and learn quickly and fail fast if they fail. And with these cornerstones, we talked about how does the first prototype that we built look like? What should it do? And for the first prototype, we decided that we want to ingest machine data and store it in the cloud in some database and have it available. Matthias mentioned already the Prenect system, and the Prenect system handles many of the printing-related processes at the customer sites already and gets in touch with a lot of machine data. It includes a message bus where all of the data goes through, and this looked like a really good starting point for our machine data. On the cloud side, we decided for the IoT core and for Lambda function to get the data from the IoT core and put it into a SQL database running in RDS. We talked to a Prenect developer who integrated an MQTT client quickly into Prenect and connected it to the IoT core. We installed this client on around 10 testing machines internally at Heidelberg to get some data into our cloud. And learned that these testing machines produce around 10,000 messages or events per day. We installed it on 10 machines, and after 10 days, we were approaching around 1 million events in our database. So the SQL database had a table, 1 million events in it after 10 days. And we already saw the problem coming up. When we wanted to add indices, wanted to change the table structure, do things like that, doing migrations in general. We introduced downtimes, maintenance windows. We started thinking about replication, master-slave setups, these things. And it didn't look right to use the SQL database at that part. So for the second prototype, we looked for solutions to this database issue. We checked the available services at AWS, found DynamoDB besides others, and decided that we give DynamoDB a try. So we replaced our SQL database with DynamoDB. With that, when looking at the solution at that time, helped a lot. So checking on our goals, the infrastructure became easier. So we could keep up the speed. We didn't make things more complex. We could reduce VPCs. We didn't have to handle the security of the endpoints in the same way as in DynamoDB. Migrations were no more issues, no downtimes related to that. The team was still fast. But we saw the issue that we can't analyze all the data now easily anymore. SQL isn't available in DynamoDB. Analyzing the data isn't really that easy. So for our next iteration, we talked to internal departments and tried to learn what are typical questions that they want to ask on the data. One of the typical questions was how many printed pages or how many pages did the customer print in a certain time frame on a specific machine. And this was a starting point for us to search for solutions on analyzing the historical data. We saw we are not the first ones with this problem, and we found a couple of patterns and best practices to solve this kind of problems. And the one that seemed most promising for us was the Lambda architecture. The Lambda architecture divides this problem into two independent parts and conquers them individually. For the one part is the historical data analysis. It's called a batch layer in the Lambda architecture. The other side is making the data available as fast as possible, basically the real-time part, and it's called the speed layer in the architecture in this pattern. For the historical, for the batch layer, the pattern describes the analysis of the data by processing the data in batches or storing it in a cheap data store. And for the speed layer, it suggests using a database and store only a very limited amount of data and only the aggregated state. So summer was starting, the cold spring was after us, and we started implementing it. And we attached the Kinesis streams to the IoT core, added the fire hose to the Kinesis stream, and Firehose puts the data in chunks into an S3 bucket. We connected Athena to the S3 bucket, and with that we were able to use SQL to analyze the data very easily. So answering the questions from internal departments was now possible, quite easy. We could easily connect typical BI solutions. We could use typical tools that are used in data science and machine learning. The response times were around a couple of seconds, which works for these analytical use cases, but that doesn't work for web application or other real-time things. For the real-time part, for the speed layer, we use the Lambda function that we previously had attached to the IoT core directly and attach it to the Kinesis stream now. And the Lambda function receives only filtered data now, only the data that is relevant for this small aspect of the speed layer, and stores only the aggregated values in the DynamoDB now. So with this, we were able to connect applications to the database, look at the real-time state, and on the other hand, we were able to analyze all the historical data and make it available for other internal departments. We deployed this solution to a couple of field test customers and talked to our product managers. What can be a good MVP to show to our field test customers and find out more about their demands on tools and the data. And the product managers talked to the customers, and one of the interesting parts from our customers, or things that customers were interested in, was seeing in a web application the current process of the prints, of the printing machines, of the jobs that are running, printing speed, things like that. We took this hints and built a web application, connected it via the API gateway to the DynamoDB. We adjusted the Lambda function and did updates to the DynamoDB with a state that was relevant for the web application. And we connected the Heidelberg account to this web application as well. The Heidelberg account is an authentication system that some of our customers were already using at this time. And we deployed this solution. So the summer was at its peak, and the tension in our team was really high, and we were really keen on finding out if we found what our customers were looking for. And yeah, we could impress our customers with the following dashboard. So the dashboard shows the state of the machines of the customer, the progress of a job that is currently running, the printing speed, the name of the job, and all these in near real time. The delay between things happening on site until it is visible here in this web application was around 2 seconds. And we did all this with a small team of 3 developers. We were able to manage and develop and operate this platform. We monitored everything ourselves. We didn't have to use the support from other teams in these processes, which helped keeping up the speed. And after this success, we took a break and thought, how can we transfer these learnings to the next steps? How can we build on our vision and use these learnings? We turned the IoT platform into one of the building blocks of this architecture, and started to set up new teams for new products in a very similar way. So the teams were as independent as possible, open on the technologies they want to use, and iterate quickly. And the first product was a remote service tool, which our internal Heidelberg technicians use to analyze machines on customer sites, transfer files to the machines, from the machine, do the remote service. We integrated them by sending data to their Kinesis stream. And the next product is an insights and analytics tool for our customers. With this tool, our customers can have access to historical data. We created reports and trends, and users can see this. We connected it via S3 buckets. They are loading the data from our S3 buckets into an analytical database, which is the basis for the reports. As a third project, we integrated the Heidelberg ERP and CRM systems that are running on premises in Wiesloch. And we used SQS queues as the technology or the interface technology. Yeah, the IT team at the end of this journey was still very small. We were 3 to 4 developers handling all the development, operation, and monitoring ourselves. We were able to reduce the delays even more, and Matthias will tell you how this helped building the vision.
Thanks, Jörg. Thanks, Jörg. Well, let's talk about some achievements. Jörg reported how we made a data platform including a first business application. And this was done completely in only 14 months. Well, taking into account our starting point and as well taking into account the complexity of such a data platform, we see this as a good example in putting idea into practice in quite a short time, which is really important to us. The data platform provides from its beginning what we call near real-time capability. And this is finally that there is a maximum delay between the data ingestion and the machine and the availability of this information in the customer's dashboard of 2 seconds. For now, this is sufficient for our demands. And we also see another achievement we see is looking at the operation cost of the platform. We see a decrease of about 50% compared to the operating cost of the platform we used before. Well, in the meantime, we continued and did further development onto the platform. We managed the global rollout, and we added another improvements to the data platform. Today, there are more than 10,000 assets connected to the platform, and we are receiving currently approximately 25 million of telemetry records any day. Another improvement for us is that we are able to manage 50 deployments per month. Maybe Some might have expected more, but taking into consideration that we previously did 2 releases per year based on our on-prem development, this is clearly a remarkable accomplishment for us, but for sure not yet the end. Based on the experiences gained, and as well encouraged of the success in building the data platform, we continued and started to build a new cloud-based Heidelberg ecosystem. And the purpose of this ecosystem is to consolidate all digital touch points and all offerings related both to our customers and as well to our internal experts. And this ecosystem will also serve as a foundation for future digital services and offerings. So we are about to add offerings based on AI, ML technology or related to machine maintenance. And we will enrich this platform step by step as well with the results of the migration of our current existing on-prem services to the cloud. We are currently working on very hard. There are some learnings we made along the way we would like to share with you. I would like to start with the learning related to the technology. Well, initially we believed that technology would be the main hurdle, but it wasn't. You can master the technical challenges in moving from on-prem to the cloud. We started this transformation with a team of well-educated and highly motivated developers experienced in building 3-tier on-prem applications. So we started with very little cloud experience. But driven by the initiative of the developers and as well supported by the AWS consultants and the AWS trainings offerings, and additionally supported by experienced external consultants like Jörg or the SOI GmbH from Stuttgart, which is one of the AWS Premier Consulting partner. We made it to inspire the whole team, and I'm talking in total about much more than 100 developers. We made it to inspire the whole team to delve into cloud technologies quickly. And after an initial start, this was something like what I would call a self-reinforcing process. So technology learning is still a continuous process, but technology know-how is for us no more the limiting factor. A second learning is related to the matter of organization within maybe larger companies. You may say this is a common phrase, but we learned that it helped us a lot that we were able to manage all major decisions within one organizational unit of our company. And we believe you have to have a single organizational unit to push visions like this successfully. A few words related to teams and to the matter of responsibility. Well, we completely changed our organization in starting, developing in the cloud. And we changed it in a way that we formed approximately 20 teams based on the principle that these teams are really able to act vertically. And based on the principle that these teams are really able to carry the responsibility resulting out of the development and operation of cloud services. And because several aspects are the same for any team, for example, UX, security, architecture, build management, and many more, we established horizontal teams across all these vertical teams, driven by representatives of any team, which is in general called councils. And we really got we really got a great experience out of the work of that council, which seems us really important. A few words related in special to the matter of the responsibility. We learned that teams must be willing to take the responsibility. But we learned as well that the organization must also be willing to transfer decision-making to the teams. And this is a kind of a learning phase, both to the teams and as well to the organization. And this learning includes the management as well, because the management must also be willing to transfer parts of the decision-making to the teams, but has to keep the general responsibility. And at last, some words related to the matter of cultural challenges. And we see all these cultural challenges maybe the most important in moving a development team from on-prem to the cloud. And the aspect of culture at first is keep in mind what agile means. You might say this is maybe some common sense, but we learned that it helps a lot to be aware of this and to have this in mind day by day. It's about to accelerate these plan, do, check, assess, circle, and it's always about to keep in mind that time to feedback beats everything and time to market counts at the end. And related to the culture as well, we learned that it is a huge challenge to enable teams to carry the responsibility for all aspects of DevOps. So we are often talking about this, about these DevSec FinOps, which is because it includes all these aspects. And this is maybe a huge challenge for any team, but it's especially a huge challenge for teams that had been used to develop on-prem software for years. So this is something we are still working on, but we are finally on a good way. And with that said, I hand over back to David.
Yeah, Matthias, Jörg, thanks so much for sharing that. I'm personally pretty excited to continue working on the digital ecosystem, expanding this to new business applications as you just showed. So yeah, great success. Thanks for sharing that. And thank you guys for listening in today. I would ask you, please take 1 minute to rate us in the AWS Events app. And after that, we will still be available here in the front. If you have any questions or want to spark up a discussion with us, we will be here until the next session starts. And you can also later visit me or my colleagues in the AWS world. We have a manufacturing booth. We have some cool demos, so check it out and have a good rest of the day. Thanks.